In the beginning, God created the heavens and the earth. Those are the first words of the Bible, and they're very clear. And they teach that the universe was brought into existence by God. But our modern world tends to be dominated by atheistic philosophy. Certainly the media are. You won't get anyone admitting to that on the television. And our education system is supposed to be based on that idea these days. Atheists start with the assumption there's no God, and then they try and explain the universe and life within it as a result just of purely random chance and natural law, and they fail. The evidence is on the side of the existence of God who created the universe. So let's start with a look at the evidence that the universe was actually brought into existence by a creator. Now, in classical times, Greek philosophers taught that the universe had always existed, and that was generally believed until, well, I'm going to say quite recently, but I mean within the last century or a half or something like that. So yet people like Isaac Newton considered the problem very slightly. He produced the question of why the force of universal gravity didn't pull all the stars together into one big mass. The universe was infinitely old. Why didn't gravity pull up all the stars together into what he called an heap? If you read Principia, the English translation, that's what he said. And the only solution to that is if the universe is infinitely big and its stars are about evenly distributed around it, or the galaxies, you didn't know about galaxies, you said stars, but galaxies would do, then there's about the same amount pulling. If you've got a star, you've got the same amount pulling on each side of it, and so the star has a total no force at all. So the star stays where it is, the universe doesn't collapse, but it has to be infinite before that can happen. And he left it at that. What he's showing is that if the universe is infinitely old, then it has to be infinitely big. Now, there's a problem with that. The German astronomer Heinrich Olbers noticed a problem in what he did was the first person apparently to notice that the sky is dark at night. Now, I suspect people had spotted that beforehand, but they haven't written about it very much. And he asked the question, why is the sky dark? Because if the sky is infinitely big, whatever direction you look in, the line of sight will end up on a star. So every direction you look in, there'll be starlight coming from it, and so the whole sky should be as bright as the surface of a star. Well, the best star we know to know how bright it is the sun, and if the whole sky was as bright as that, it'd be pretty hot. So, and he noticed it definitely isn't like that. So he came up with the idea the universe must be finite as a result. But if it's finite, then it should have, if it's infinitely old, it should have all collapsed together into one heap. And it hasn't done that. And at the time, people couldn't answer that problem. They had no idea what the answer was, so they said it's a paradox. And it was known as Olbers' paradox. Now there's a second point as well, because even though the night sky is dark, there's a lot of stars in it. Well, it's not cloudy. In Manchester we don't see stars very often, but in Liverpool no doubt you've seen them and you know what they're around. And those stars produce light by burning nuclear fuel. Now, if the universe was infinitely old, then the fuel by now would have been used up. And so the stars would have gone out. It's called heat death in the end, the idea that everything used up and everything's just evenly spread out through the universe. And that's what you'd expect to get. But the fact that stars exist also show that there's something around it. Now, the atheists are uneasy about that idea. But nothing really happened about it. Now, the next thing that happens is that Albert Einstein produced a set of equations which talk about the size of the universe, and he showed that, he started off by showing that the universe is either collapsing or expanding. Didn't like that, and so fudged his equations to give a solution where it's stationary, but it's a very, very unstable equilibrium. Anything that disturbed it would cause either collapse or expand. And very soon the people were saying, well, the best solution is, there's a chap called Lemaitre who launched it, the best solution is that the universe started off with a creation event and it's been expanding from that. Atheists didn't like that. They said, no, we've got, later on, the evidence that the universe is expanding appeared in spectra of stars. And so the atheists didn't like that, and they devised the idea of a steady state theory where there's little tiny bits of creation going on all the time to try and fill the spaces that the expansion leaves behind. That's called the steady state theory, and they tried to belittle the idea that there was a creation event by renaming it. Instead of calling it the creation theory, they call it the Big Bang theory. And so the phrase Big Bang theory is an attempt to belittle the idea that there was a moment of creation that really took place. Now, it was then all sorts of bits of evidence told us paradox. In fact, stars are still burning, but you'd expect if there was a creation event that it would leave echoes in the sky in terms of thermal radiation, which has cooled down to microwave radiation, and it would have a thermal spectrum. No one found it initially, but then these two characters here, these are called Penzias and Wilson, that's their surnames. They were using this thing, which is a sort of radio telescope. It's not really built as a telescope, it's designed to detect microwaves. They were looking for interference on telephone networks. Often there were microwaves that we used to transmit telephone messages, and there was a funny hiss that they kept on getting, so they were trying to find out where it was coming from by pointing this in all different directions, and they found that more or less every bit of the sky, absolutely evenly, or apparently absolutely evenly, was generating this microwave background. They refer to it as cosmic microwave background radiation. And it matched up with what the theoreticians were telling the idea of a creation event should have produced. And in fact, they could work out the spectrum that it should look like. If you plot it's the wave number, it's a measure of the frequency that way, and on this way you measure the intensity, then you should get a curve like that. That's what you would get. Penzias and Wilson couldn't measure that because there's lots of absorption by the atmosphere, which tends to put it off slightly. But they sent a satellite, the Cosmic Background Explorer, COBE, and that measured the spectrum very accurately. And in fact, it's so close that I can't draw a line that's thin enough to show the difference between the measured values and the values that the idea of a creation predicts. So the Big Bang theory predicts that curve, and that's the curve you see, and it's exactly right. And then they sent up other satellites which have confirmed it since. It all fits in quite nicely. There's lots of evidence keeps on coming in, and it all shows beyond any doubt the universe came into existence as the result of a single creation event. Now, let's think about what that means. I want to start off with two definitions. The first one is a definition of the idea of contingency. Something is contingent if it doesn't have to be like it is. So the notes that I've got for this talk, for example, don't have to be like they are. I could put the words in a different way. I could explain things differently. I could have got fewer spelling mistakes. It could have been grammatical, might be no crossings out, all sorts of things that will be different about it. It doesn't have to be as it is. And that means it needs an explanation. Something that's contingent, that doesn't have to be as it is, needs something to explain why it is like it is. Well, my poor education, or whatever it happens to be, that leaves me with lots and lots of spelling mistakes. Or the fact they exist at all. Something not existing, that will be different. So I might never have written those. Or I might not have, say, what's the cause? These notes have a cause, which is I got a pen and wrote them. Then you can say, all right, well, you're contingent as well. What's your cause? Well, I've got parents. And so on. We can keep on tracking back lines of cause. Any contingent entity has to have a cause. The other kind of entity you can have is called a necessary entity. So if it's not contingent, then it's necessary. So a necessary entity doesn't have to have an explanation. It's explained by itself. Things you can say about necessary entities, they have to be infinitely old, or at least they have no beginning. If there's a time when they didn't exist, they don't have to exist. And there's nothing that can limit them, because then you'd have something else that explain what they were like. So, and a necessary entity is a very unusual kind of, I'm going to say strange, it's strange to us, because none of us is necessary, we're all contingent. Contingent entities require an explanation, and the universe we just showed is contingent. It came into existence. There was a time before which it did not exist. And so we can go on and make that into a sort of logical argument, put it properly. So first of all, we say some things in the universe exist. Almost everyone here will agree with that, right? It's possible for those things not to exist. There's no reason why this school has to be here. Someone built it, that's why it's here. So there is a reason, but it's not logically required by the fabric of reality. You could have built it somewhere else, they could have not built it at all. So there are things that exist, and it's possible for those not to exist. And those have to be caused to exist, and they have to be caused to exist by something else. And if that's contingent, that needs a cause, and so on, going on back. But there's no point in going back forever. There's a story that gets told sometimes about the turtles. You know, there's an astronomy lecture, and the elderly lady at the back says, "You're wrong, young man. The Earth is placed on the back of a turtle." And the lecturer says, "Well, what's the turtle on?" And she says, "Oh, another turtle." He says, "Well, what's that on?" She says, "You can't fool me, young man. From there on, it's turtles all the way down." And it's a regularly told story, and often it's told, and they say, "There you are, I proved that there's something wrong with your argument." Actually, it proves my argument's correct. The point is that any collection of contingent entities is itself contingent. You've got an infinite pile of turtles. What you've got is an infinite pile of falling turtles, because there's nothing to hold the pile up. And if you've got an infinite infinite chain of cause and effect, then that's no use. You've got to have something to cause the chain. And another thing you can think of a railway train. Think of a carriage in a railway train. Why is that moving? Well, it's being pulled along by the carriage in front of it through a coupling. And that's being pulled along by the carriage in front of that. But sooner or later you've got to have an engine, or the whole lot won't move. And this is the same idea. In the end, your chain of cause and effect has to have something that doesn't need a cause. It has to have a necessary entity at the beginning of it. And that necessary entity is God. The God of the Bible has the properties of the necessary entity that caused the universe. You work out logically what they are. There's more about the God of the Bible. You know more about the God of the Bible than you do about just that it's necessary. But it has to be necessary. So, let's move on now to the second line of reasoning. That's the idea of design. If an object is designed, then it has to have a designer. That's almost a given. The whole point about it being designed is that someone designed it. Now, and that designer must have the capacity to reason, and he must have a purpose. Why did he make it? He made it for a reason. And he has to have the power to give the design substance. The problem is how we recognise that an object has been designed. Now, I don't know if you know what that is. That was dug up. Well, no, it was brought up by fishermen from the floor of the Aegean Sea, along with some coins and bits of sculpture and so on. It took a while for them to work out what it was, but they could date it to about 150 BC. And if you look at it, it's clearly got a wheel. And if you look at it even more carefully, you can see it's a cogwheel. And there are a whole lot of cogwheels in some kind of clockwork device with a wooden box around them, which has disappeared actually. The wooden box is pretty well rotted away. And they call it the Antikythera mechanism. It's found off the island of Antikythera. Now, nobody looked at that and said, "Oh, doesn't random chance make a funny looking device?" They looked it up, they pulled it up and said, "We didn't know the ancient Greeks could make cogwheels, but obviously they could, because this was never something that occurred by chance. It's obviously a designed object. And the point is, if something like that's obviously designed, then living things, just take one example, are much more complicated than the Antikythera mechanism. So you come across that, you ought to be thinking maybe that was designed as well. William Paley is the famous character who philosophized about it, as it were, and he said, supposing I'm walking across the heath, and I come across a stone on the floor, and my foot pitches up against it, and I look at it, and someone says, why is that there? I might just say, oh, well, for I know it's always been there, just a random bit of stone. But he says, if I find a watch in the grass instead, then I can deduce that there's been a watchmaker who's made that watch. And he set up a set of conditions. How would you know if something was designed? He says, well, first of all, if a system is made of several distinct and different parts, and those parts all act together to achieve some result, and if you put the parts in a different order, you took some of the parts out and put them back in a different order, you just took them away, the thing would stop working, then that complexity shows you've got something that's designed. Obviously there could be other things that are designed. I think I've got an example, there you go, that's a sculpture in Manchester, which is designed to look like a very large pebble. It was very definitely designed and made. It's not a very large pebble, it's a designed and made object, but you might not notice that if you happen to come across it, you might think that was natural. So you could have something designed to look random, but nevertheless, if you find something that has lots of parts, and the parts all have to work together before the thing can achieve its objective, and if you change the parts, or you rearrange them in a different order, then the thing stops working. Now that means it's been designed. And the question is, can we think of anything like that? Well, there are all sorts of things. That's one of them. There are all sorts of living things. I haven't got time to do them all. It'll take you about 10 years or 20 years, something like that maybe. I probably want to drink before then. But that's an ichneumon fly. And what it does is it lays its egg on the back of a wood wasp. It's one kind of wood wasp on a Syrinx wood wasp. The difficulty is that the Syrinx grub it's going to lay its egg on the back of is under about anywhere between an inch and 2 inches of solid wood. And that makes it difficult for the ichneumon fly to lay an egg on it. So what it does is it flies onto the wood, and it's got a drill. There it is. It drills a hole down through the wood. It has to detect where the grub is in the first place. It flies along, detect the grub, land, drill a hole, and then when it's made the hole, got to the bottom back of the wasp, it's got another tube at the back there called an ovipositor. It sticks that down the hole, and it's got a rugby ball shaped egg, so it will fit nicely. It gets pushed down the tube and laid on the back of the Syrinx wasp, and then the ichneumon fly goes off and repeats the operation on another Syrinx wasp. No one's dead certain how it detects the Syrinx wasp in the first place. They know how the drill works and the ovipositor, but they're quite amazing that it can drill. Presumably the Syrinx can hear the drill coming, so it has to drill very fast to get to the grub before it can get away. It's got to lay its egg in just the right place on the sort of back of the Syrinx wasp's neck, or the Syrinx wasp will to bite it off. So it's a pretty clever device, and there it is. It's a living creature. Now, to me, that sounds very like something that's designed. If you take away any part of it, take away the ability to find the grub, the rest of it's useless. Take away the drill. In fact, you can find a wasp is quite good, but the drill, without the drill, it can't get down. If it's got a hole and it's got a tube to lay eggs down, it's stuck. If the egg's round, it won't be able to get down the hole anyway. All those have to happen at once. Another example, famous one, the bombardier beetle. What it does, it defends itself from predators by firing boiling hot mix of chemicals out of its rear end. And to do that, it has a very specialised anatomy. It makes two chemicals, very energetic chemical called hydroquinone and a strong oxidizing agent called hydrogen peroxide, and it mixes them together. You know how powerful that mix could be. They're trying it with something less energetic, which was flour and hydrogen peroxide. You got the 7-7 bombs in London. That's the same basic chemistry as the back end of a bombardier beetle. So you've got something that's fairly energetic, but you can actually mix the two together in a bottle on your workbench, and as long as you don't drop it or set fire to it or something, heat it up, you could you stay there a very long time. You know, the London bombers got to London on the train, and even British Rail didn't manage to set the bombs off. So it's something that needs to stop. And what it does is it puts two enzymes in, which together cause the reaction to start, and you get a sudden heating of the liquid. It's only a very small amount, and that then throws it out the back, and you get red hot mix of probably by now water and whatever hydroquinone turns into when it's been oxidized, thrown out the back end of the beetle, which puts off any predator that happens to be going for it. But for that to work, you've got to have a lot of bits. First of all, it's got to want to make hydroquinone, it's got to make hydrogen peroxide, it's got to put them together, and it's got to make them go off. Not just that, it's got to have a very sort of armoured rear cavity, or else it could be a slightly problem. If you can have this armoured valve, it's got to mix them together, then expels them into the combustion chamber, it closes the door and squirts out the enzyme, and bang. If it didn't have the armoured door, or this wasn't thick enough, then it would blow its bottom off instead, which is definitely not a survival strategy. Again, it's difficult to see how that could happen by anything other than a designer having put it together. If you go on the internet, you'll find that there are lots and lots of attempts to explain how something like that could happen, and they all miss the point that it's useless without lots of the bits. And if you take away some of the bits, you can suddenly get an explosion that kills the beetle. So that's the bombardier beetle. Because of the complexity of the system, it has to be together all in one go. It has every sign of design. Now, the way people escape from that, or attempt to escape from that, is by saying, oh well, it evolved. And that idea was proposed by Charles Darwin. There he is, that's his statue in the Natural History Museum. It's quite fascinating. If you stand on the bridge opposite, you can see people going up to it, and there's obviously some quiz for children. You'll get down in front of it. It's I don't know if that's deliberate, but it looks. I must get a photograph of that next time I go anywhere near. But the idea of the theory, he wrote a book called On the Origin of Species. It's quite a lot longer than that, but that's the general name. Anyway, the general idea of that theory is that individuals within a species vary from one to another. Fair enough, that happens, and that's due to random mutations, and again, there's no reason to doubt that. And that natural selection will favour the best fitted mutations so that the frequency with which they're represented will increase, and then they will have offspring who also mutate, and so on. And you'll get changes in the form of whatever animal you're dealing with. Not only that, you can separate them off. So you might find that one place it favours one form, another place it favours another form, and you get quite different looking organisms turning up. If you repeat that over and over again, then gradually the species will change form, or maybe it'll even get two different forms. And we're used to that idea. There you go. As a dog, you can all think of lots of different kinds of dog, Great Danes, Chihuahuas, collie dogs, lots and lots of different kinds of dogs around. And they have been produced, alright, it's artificial selection rather than natural selection, but it nevertheless shows that species can change. Of course, the Bible's quite happy with a bit of evolution as well. Adam and Eve, the first man, and everybody else is descended from them. But if you look around the room, you can see we all look different. So there's been a certain amount of evolution going on. But we call that microevolution. It's talking about small changes within species. We're not talking about a major change. You can get dogs and breed dogs. You can breed a different kind of dog in time. However, what they require to explain all these organisms isn't just these very tiny changes, it's really big change that takes you from a single-celled creature up to things like us. That macroevolution is something that's a bit short on evidence, shall we say. You can breed different kinds of dogs from one pair of dogs. You can breed dogs a long time before you get a cat or a banana. Right? So I haven't noticed anybody managing to breed dogs and come up with a banana. It's so far not been done, and I suspect never will be. And the two requirements of the theory of macroevolution, one of them is that there is a variable chain of organisms. You can't end up going through something that dies off. If you start off with, some horses, you can breed more horses. If you start with donkeys, you can breed more donkeys. You can breed a horse and donkey together and get a mule, but you can have as many mules as you like, you won't get another mule, because mules are sterile. And you've reached the limit of how far it's gone. Possibly horses and donkeys at some time in the past had a common ancestor, and they've separated. Maybe they have, maybe they haven't, I don't know. But the point is that you can't take the variation too far before it gives up. And that's true of every species there is. You can't breed a dog with a cat. Khrushchev used to say you can't breed a snake and a hedgehog. I don't know why, but he did. The other thing that's predicted is the idea that it's a gradual change. Mutations are only ever small things, so you might get a bit bigger, different colour, slight changes. And each of those changes has to be viable, it has to be possibly live, and there has to be an advantage in it, or at least no disadvantage. Otherwise, natural selection will get rid of it. So, it's possible that there is something halfway between a dog and a banana, it probably doesn't have a really big viability. It's able to die out, and hence natural selection will get rid of it very quickly. So this idea that everything gradually changes from one to another is another prediction of the theory of evolution, and that doesn't work either. That's a picture of the geological ages. If you get any textbook on geology or paleontology, they'll all show pretty well the same one. They might disagree at the top with the numbers slightly. You won't get them put in a different order. They'll all agree that the Carboniferous period was followed by the Permian period, and that there was a sudden change in between them. Dinosaurs carry on right up to the end of the Cretaceous, and then there are no more dinosaurs. And the gap in the rock between the two is no more than 150 years. Actually, it could be a lot shorter than that if there's a catastrophe like a meteorite hitting the Earth, which is what they think happened now. And suddenly you've got a completely new fauna appearing from nowhere, apparently. It's not this gradual development that you ought to get from a single-cell animal going all the way through to human beings, monkeys, bananas, cats, through a continuous set of changes. You don't see that. What you see is this set of very sudden changes. Let's think of one particular case there. Think about the origin of birds. The general evolutionary explanation is that birds arose by evolution from dinosaurs. There's a bit of a problem because you actually need a lot of changes. There are a lot of features for a bird. So for a bird to work, it's got to have big wings that'll hold the air. It's going to fly. There's no point having little wings that can't fly unless you're balancing when you're running or something like that. If you're an ostrich and have the wings, then you could lose the function, but the other way doesn't work. It's got to have flight feathers. You clip the wings on a bird, it stops being able to fly. It's got to have strong muscles that will power the wing beats. It has great big wings. If you put great big wings on me, I won't be able to flap them because my muscles are rather poor by comparison with a bird's muscles. It's got to have something to attach the muscles to. If you put big muscles on me, then it'll just break my bones. On the bird, there's a thing called a keel, which is a big, large piece of cartilage at the front. If you're carving a chicken, you can see them, that the great big flight muscles attached to. It's got to be able to supply oxygen to the muscles. It's no good having big muscles fastened down that could do lots and lots of work. If you can't get oxygen to them fast enough, It'll do 2 or 3 beats and then it won't be able to do anything else. And it's got to have a lightweight frame so that it can get off the ground. And for a bird you need all those things. So people say, well, oh yes, but there's a missing link between dinosaurs and birds. There it is, Archaeopteryx. Problem is, if you look at it, it doesn't have the features of a bird. Yeah, you can see it's got feathers of some kind. I don't know if they're flight feathers or not. There's no Archaeopteryx fossil which is distinct enough for you to see anything other than that there's something like a feather. I spent a long time looking at the one in the Natural History Museum. My wife moved me on in the end when I went down there. And you definitely can't distinguish what kind of, there's obviously some kind of feather on it, but that's all you can distinguish. But if you look at this, look for the keel bone. Remember on a bird, when you carve your chicken, you find there's this big structure that the muscles attached to. It isn't there. The ribs aren't the kind of ribs that you see on a bird. You don't get this sort of very concave shape. The legs are lizard legs, both ends. What you've got is a tail. What you've got is a feathered lizard, very definitely. It's not somewhere between a bird and a dinosaur. In fact, I've talked to a couple of paleontologists about it. They say it isn't the ancestor of a bird, and every paleontologist knows it isn't the ancestor of a bird anyway. In fact, they've now found a fossil bird that's older than Archaeopteryx. So there are already birds around when Archaeopteryx was doing its thing. It isn't a missing link, but even if it was, a missing link doesn't get rid of it. What you need is a continuous change from some kind of dinosaur to some kind of bird. And in fact, there are bigger problems. The way that lungs work on a bird. Lungs on a bird don't work like your lungs. Your lungs, reptiles' lungs, work the same way. Amphibian lungs, for that matter. You breathe in, you breathe out. You've got a sort of sac in the middle, which is blood vessels in it, and that's where the gas exchange takes place. In a bird, it doesn't work like that. You've got tube to the mouth, or 2 little holes on the beak. Air goes in there, goes to a sort of, well, it's always at the back, an air sac at the back, and there's another one at the front there, and then there is a very stiff set of tubes in between called parabronchi. What happens is the thing starts to breathe in, that breathes in, the air comes in down there and goes into the air sac. This one here is also sucking in, so some air across with the parabronchi. Next thing, it now breathes out, so it pushes the air out of that. The old air goes out here, and the air's pushed from there through, and it will try and go out of there if it can. Then you get another breathe in, the air sucked through the parabronchi still, and the new breath goes into the posterior air sac, and finally it breathes out again, and the air is finally expelled. So there's always air, all the time there's always air going through the lungs, so it's as though you're always breathing in and out at the same time. Very much more efficient than our lungs are, at the expense of a lot more organisation inside. But there's no way you can make those out of the kind of lungs that a reptile has. The only thing that happens, you have to disconnect all the tubes at some point. At that point, you've got a dead organism. Your lungs aren't connected. You've had it. I've been put to a couple of biologists by my son, and they said, well, there have to be some kind of other kind of dinosaur that have that kind of breathing. And he said, well, where did they get it from? And they said, well, they must have evolved directly from insects. It doesn't really. I don't find that credible, put it that way. Really explain it. So, again, going back to the reptile bird gap, it's the problem is repeated over and over again. Every one of these gaps with a blue bit and a white bit, or the other way around, has a completely new set of species appearing from nowhere. Each of them has lots of structures that you can't explain in terms of gradual changes from earlier ones. And it's absolutely clear, it's crystal clear, that there is no record of gradual change from primitive organisms. And that's completely contrary to the predictions made by the theory of evolution. And there's a lot said, about biological design. Atheists who are honest will admit that there are large numbers of places where there's no apparent route by which an organism or a system evolved, and often their commitment to atheistic philosophy is such they'll claim that, well, an evolutionary explanation, we don't know what it is yet, but it must exist, and maybe one day we'll find it. But it's very much a blind faith. Is that it's against all logic and it's against all the evidence. And of course, there's one system that hasn't evolved, because it's got no children, and that's the universe itself. And the universe certainly hasn't. Now, it's only since the 1980s that we've really been able to appreciate how narrow the design tolerances in the universe actually are. It's very, very carefully designed to allow life to exist. So, for example, think about water. Water is absolutely vitally important to maintain life. You've got to have something that's a nicely polar fluid, that's got a high specific heat capacity, and so on. It's got to have lots and lots of properties. Water has all of them. But it's rather odd. For example, ice is less dense than water. You get you're cooking fat, and you'll find that you put a bit more cooking fat in an already melted bit, it just sinks straight to the bottom. It doesn't float. And that's true of just about every other substance. The solid is more dense than the liquid, but for ice, water, ice floats on top. And that's really very useful, because if the ice didn't float, sank to the bottom, and you get another layer of ice forming on top, that would sink and so on, until in the end the whole lot floats through, and the whole planet would look like that, except there would be no person on it to it'll be covered in ice all the time. So water has to have a rather unusual property there. If water wasn't so common, it would be a really weird laboratory curiosity, and people would be queuing up to see it in a museum. But if you live in Manchester, it comes out of the sky. So quite often you can predict how chemicals work. There's a thing called the periodic table that has the different atoms or different chemical elements across the top. And if you go down a column of it, then you find that group of elements all do the same thing. So some examples there. This set, for example, here, it's called the noble gases or the inert gases, and they're all pretty well the same. They're gaseous. They don't react with anything else very much. This lot here called halogens. They all react the same way with very, very heavy with elements over the other side. And you get, for example, you get sodium. You can have sodium fluoride, sodium chloride, sodium bromide, and so on, and it will be the same sort of substance. This end here, these are alkali earths. Forget the H at the top. Hydrogen is a strange thing. It appears twice. Sometimes it appears there as well. But the others, lithium, sodium, they're all metals which produce alkaline residues when they're burned, and so on. They're similar. So when you get to the this group and the hydrides there, then you'd expect them all to be the same, and actually they are once you ignore oxygen. So if you plot, for example, the melting point and the boiling point, then you can see hydrogen telluride is a smelly gas, very, very smelly. Hydrogen selenide is a very smelly gas, not quite as smelly as hydrogen telluride, but still pretty smelly. Hydrogen sulfide, H2S, stink bomb stuff, that's a pretty smelly gas, but not quite as smelly as the other two. And you'd expect slightly less smelly, but still pretty smelly gas, H2O. But it isn't, it's a liquid. If you look at the melting point and the boiling point, they're, first of all, a lot higher, so it's a liquid, at ordinary temperatures around here. Secondly, the distance between the melting point and the boiling point is a lot higher than it is for the two. So there's a lot more variety of temperatures where it can be liquid, which is very useful for life. If the water only had a sort of 10 degree, 15 degree gap between melting and boiling, then all the water will boil every day and it'll freeze every night. It doesn't, it's got this nice wide gap to it, it's very nicely designed. And it does that because of hydrogen bonding, or it's a special kind of chemical bond, which only occurs in a very small number of elements. And it does that because the sort of basic physics of the situation says that just balance very finely for water to behave like that. Now, there's a chap called, well, Astronomer Royal, Martin Rees, wrote a book called Just 6 Numbers. He's talking about just 6 of the fundamental constants of the universe that control how the universe works. There's probably about 30 that really make a difference to it, but he's just writing about 6 of them. And he shows that if any one of those 6 numbers had a tiny amount different, then the universe wouldn't work properly. Examples: beta decay. You've all come across beta decay. You've got a neutron. So neutrons bound in a nucleus, it doesn't decay. If it's on its own, about 10 minutes on average, it will break up into a proton, an electron, and an antineutrino. Yeah? And that's used in things like stars burning. It's a common reaction for it to happen. Didn't happen, no stars. And you can look at the energy. So you start off with a neutron. It's got a mass of 939.6 MeV, and a proton has got a lower mass, right? And an electron's got a mass of about half an MeV. If you add them together, then you can see you've got about 0.8 MeV of spare energy, which goes into separating the objects and into the antineutrino. You have to have that. If that energy there was negative or 0, then you wouldn't get the decay. It's quite small, you only get a very slow decay. It's a lot bigger, you get a very much more powerful decay. So that amount of excess energy is important. Now if you think how the mass of the neutron is not controlled by anything else, it's just its own mass. If you increase the mass of a neutron, it gets more than that, then even a bound neutron will decay. So all the neutrons in the universe, in about, on average, 10 minutes, takes half of them will go every 10 minutes, would decay into protons, and the only thing you'd have will be hydrogen. You'd have no chemistry. You have no chemistry teachers. Because there'd be no life. Right? If you take it the other way, if you reduce the neutron mass, if it gets down to there, then you've not got enough spare energy to let the beta decay happen. Stars won't burn. If you go down a bit further, below the proton mass, an electron below the proton mass, then all the protons will decay into neutrons instead. It will go backwards. And all you'll have is neutrons. There'll be no chemical elements, and back to the chemistry teacher problem. The neutron has to have its mass just inside a very small range. All plotted together. It's a bad idea to plot graphs where you don't see the 0. There you go, that's 0 mass. That's the mass of a neutron or a proton. They're so close together that it's that slightly thick line. This lot here, a very narrow line. Up there, 1 part in 1,000 either way, changing the mass of a neutron, and life as we know it becomes impossible. That's quite a wide tolerance by comparison with some things. This is out of Stephen Hawking must have wished he'd never written it, but he worked out the energy of the Big Bang. The energy of the Big Bang was a little bit less, then the universe wouldn't have expanded for very long. 20 minutes or so later it would have collapsed, and you wouldn't have had time for breakfast, let alone time for human civilization to develop before the universe vanished. On the other hand, if it's the energy of the universe is large, rather curiously, this omega parameter, is the energy you need divided by the energy you've got. So the smaller it is, the more energy you've got, which is the wrong way up for me. But if it's very much less, less than 1 is omega, it's a lot more energy, then the universe blows itself apart, and you don't get galaxies or stars or even atoms. They get blown apart before the universe can form, before they can properly form. So again, no life. And what Hawking's worked out was that it has to be equal to 1 to within 1 part in 10 to the power 15, so it's write that down in real numbers. 10 to the 15, so 1 with 15 zeros after it. So it's 1,000 million. It's around, the energy changes by 1 part in 1,000 million, then no life, or nothing worth bothering with. So you have a very, very tight amount of tuning. If you think about it in terms of a dial, you've got to get the dial just right for it to work, then you're talking about 1 part in 1,000 million. So if it's the size of the Earth, then you've got something which would be less than the size of an atomic nucleus. Get it right in. It couldn't be done. So the fact the universe is extremely finely tuned was unknown in the 1980s, but by the middle of the 1990s, accepted by all but a tiny handful of die-hard atheists. Science is on the side of God. So I'm going to summarise now. We're running out of time. So let's see what we've seen. First of all, we saw that the universe had a beginning. Right? It came into existence as the result of a special event, and the universe has to be contingent. It could be different. It might even not exist. So therefore, there has to be something that caused the universe to come into existence, and in the end, the ultimate cause has to be something very special that didn't have to be created itself. And that's an absolute guarantee. Secondly, living creatures show signs of having been designed by a powerful and a purposeful agent, something that had or someone or some entity that had the intelligence to get it right and a reason for doing it. So had a purpose and thought to do it. And we also saw the laws of nature that govern the universe are very finely tuned. And again, it's almost impossible to believe that the universe is like that just by chance. There's one of my colleagues at work did, one days when I was still employed, did a survey of the scientists in the faculty I worked in at university, and he found that 60% of them were very keen believers in creation, and that's when you take away the engineers who were a little less convinced, and the computer scientists who definitely weren't convinced. That made actually a very high proportion of the actual scientists, the sort of physical scientists and the chemical scientists and so on, who were there believing that the universe was created. Science is on the side of God. Actually, it's this fine-tuning thing that's made the big difference about it. But it's quite interesting. Everything we've seen speaks of a designer. Even the laws of nature are strange because they're comprehensible. You can understand them. You have to do experiments. You have to think hard about it. But you can decode them. That's what Einstein said about them. They're there and they're understandable. The only incomprehensible. He said it in German actually. Yeah. But actually, translated, the only incomprehensible thing about the universe is that it is comprehensible, is what he said. Effectively, the laws of nature are a message written in code. If you've got a message, then it's been written by someone. The message is a bit strange if it's not come from anyone. And the author of the universe is the God who reveals himself in the Bible. And there we finish.